So thank you all for being here. We are going to get started on the Chapter 4 test review. Just going to take it one question at a time. If you already did it, that is absolutely awesome. We're going to work on grading. I'll work on grading that sometime later today. So find the exact value of these trig functions. It says sine of 8 pi over 3, cosine of 8 pi over 3. It's all 8 pi over 3. So here's what we're going to do. We're going to need to utilize a unit circle some, but I notice 8 pi over 3, when I look at a unit circle, 8 pi over 3, 8/3 is bigger than 2, which means 8 pi over 3 is bigger than 2 pi. We can't see 8 pi over 3 anywhere on my unit circle. So I'm going to subtract 2 pi from 8 pi over 3 to find my reference angle in here. And then we're just going to remember, like, sine is the y value, cosine is the x value, and all that good stuff. So let me get that up in the smart notebook. So this is number 1. I want the sine of pi over 8, or sorry, not pi over 8, 3 pi, 8 pi over 3. There are ways to find like pi over 8 utilizing the unit circle, but that is more complex, and we're not covering that this year. So you don't have to worry about that. Double angle, half angle formulas. We'd love to get into chapter 5, but time said otherwise. Cosecant of 8 pi over 3, the secant of 8 pi over 3, and then the cotangent of 8 pi over 3. So, like I said, I need to find that reference angle with it. So 8 pi over 3 minus 2 pi, well, that's equal to 8 pi over 3 minus 6 pi over 3, just getting my common denominator there. And then 8 minus 6 will give me 2 pi over 3. So I can think of these all as 2 pi over 3 instead of 8 pi over 3. Now remember, sine is the y value, cosine equals the x value, tangent is y over x, cosecant is the reciprocal of sine, so that's 1 over y, secant is the reciprocal of cosine, that's 1 over x, and cotangent is the reciprocal of tangent, that is x over y. So right away, if you have the unit circle memorized, that's great. If you don't, you can reference it. So if I'm at 3 pi over 2, so okay, pi or 2 pi over 3, 2 pi's over here, that's like a 60-degree angle. So okay, I'm at 120. So I was stable at the point 1, 0. So now my y, or sorry, 0, 1. Now my y's are counting down. So my y value here should be root 3 over 2. My x value should be negative 1/2. Again, if you're like, whoa, where'd you get those values from? That's what I'm talking about, having this unit circle memorized. However, if you have not taken the time to memorize it, let's look at the unit circle. If I'm at 2 pi over 3, I see my x value is negative 1/2, and my y value is root 3 over 2. So again, I had them memorized from the unit circle. Again, I did encourage you guys to do that. I had no way to formally assess that you memorized it. So that was all in like an honor system, like, hey, do it yourself. But, you know, that's where I pulled those values from. So now I know what my y and x value are. Just go keep working from there. So tangent is y root 3. Sorry, let me write that a little neater. Root 3 over 2 divided by -1/2. Again, when I have that fraction as a denominator, I like to rewrite that as root 3 over 2 times the reciprocal of that. So that'd be 2 over -1. 2's cancel. So tangent is just, let me move this work up just a little bit so I have more room to write. So that's just going to be negative root 3. Okay, cosecant is just the reciprocal of this. So that's going to be 2 over root 3. However, we don't like square roots in our denominator, so I'm going to very quickly rationalize this in green. So I'm just going to multiply both numerator and denominator by square root of 3. So that's going to give me 2 root 3 over root 3 times root 3. It's just 3. Okay? Secant is the reciprocal of cosine. So the reciprocal of -1/2 is just simply -2. So all I did was take the reciprocal of this. I skipped that step of writing it as like 2 over -1, and they'd be like, oh, 2 divided by -1, just -2. I felt that was a pretty easy step to skip there. Then finally, we had cotangent. Cotangent's another one we're going to have to rationalize. I'm going to do it with y over x, so you're getting a little more familiar with like how to deal with that. However, since we know what tangent is, you could start with just taking the reciprocal of the final tangent answer. So I could write it as 1 over -root 3 and then rationalize that. You will get the same answer. I'm just going to do it a little bit the longer way. So I take my x value, -1/2, over my y value, root 3 over 2. So again, I don't like having fractions inside a fraction. So I'm going to write this as -1/2 times the reciprocal of the denominator. So that's 2 over root 3. Those cancel, giving me -1 over root 3. And I had just stated that's the reciprocal of my tangent value. Again, it doesn't matter which way you took it, it's the same. So then I just need to rationalize this. Again, I'll do that in green. Multiply numerator and denominator by root 3. And we'll get negative square root of 3 over 3. Root 3 times root 3 is just 3. So that's everything. Now look, when it comes time for the test, I wrote like, oh, sine is your y value, cosine is your x value, tangent is y over x. I don't need to see that from you. I'm writing that for you for notes purposes. If you like to write that for that reminder of what you're looking for, great, go ahead and do that. If you're like, wait, I remember sines y, cosines x, tangent is x over or y over x. Like, I don't need to write that down. That's absolutely fine. So all of this came from the unit circle. Remember, I looked at 2 pi over 3, and that's where I got my x and y values from on the unit circle. So I know that was a decent amount of writing. I'm not going to take the time to retype it all into here just to save us time. But remember, we do have the math symbol, so you can like put like square roots in there if you wish, or you can just use the picture option. So I'm not taking the time to export this as a picture right now, but like if you wrote it all down on something, you can always just upload a picture to me. That will be posted for you as well. Oh, this, give the period and give the amplitude use radians for the period. So we really didn't talk about graphing in terms of degrees. Technically, if I were to graph it in degrees, it'd be 360 degrees is one period. But that's why we like radians. If I had to scale my x-axis out to 360, that's massive. If I'm scaling it to 2 pi, that's not so bad. So the period here, remember the period is equal to 2, where's pi? I don't have pi as a symbol in the math. I'm not seeing it. That's odd. I'm not seeing it. Maybe I'm just overlooking it because it's slightly blurry. I'm just going to write as 2 pi divided by b. My b value here is 2. So that ends up being 2 pi divided by 2, which is just pi. So my period here is pi. If we wanted to look on Desmos to confirm that, we would see that. Now my amplitude is literally just the 3 in front. Period's a little trickier because we have to do the 2 pi divided by whatever is inside of there. So again, this is my b value equals 2. That's coming from right here. Now my amplitude is just 3. So I could just be like amplitude equals 3. And that's it. Not too bad, just identifying that information off of the equation. And honestly, you know, there's really not much work to even show for that. It's just about being able to read the equation. So not too much to do there. Another one, same thing. So here, I have -4 times the cosine of 1/3 of x. So my b value equals 1/3. So for my period, I'm going to write this one out a little more. So for my period, that's going to be equal to 2 pi divided by 1/3. So that's going to be 2 pi times 3 over 1, which is 6 pi. So again, this is one. That's my work being shown. Yeah, I'll type it out. It's not that hard to type out. So my period equals 2 pi divided by the quantity 1/3. So that's equal to 2 pi times 3 over 1, which is equal to just 6 pi. My amplitude, I'm just going to ignore the negative in front of the 4 because the negative flips it over the x-axis. Look, if you told me the amplitude is -4, I'm not taking off points on that. However, we look at the amplitude as an absolute value type thing, so I'm just going to see the amplitude is 4. Make sense?
So we always divide 2 pi by b.
Yep, always divide 2 pi by b. That's our formula to find the period. If you want the frequency, you just do the reciprocal of this. You do b divided by 2 pi. So now we're going to work it backwards. We're going to write the equation of a cosine graph with an amplitude of 2 and a period of 4 pi. So the amplitude of 2 is super easy. So that's going to be y equals 2 times the cosine of, now the period's where it gets slightly trickier. So for the period, actually I'm going to do this one back in Smart Notebook. This was number 4. So the period equals 4 pi. The amplitude equals 2. And it's a cosine. So again, that's just there, 2 times the cosine of. Now I need to figure out what that b value is. I'm going to work that the period's equal to 2 pi divided by b. Well, I know what the period is. I can say 4 pi is equal to 2 pi divided by b. So I just work that formula backwards out, and I'm going to solve for b. To start solving this, I can multiply both sides by b. So that gives me 4b pi is equal to 2 pi. I can divide both sides by 4 pi. The pi's cancel there, pi's cancel there, 4's cancel there. So b is equal to 2 over 4, or 1/2. So that will be 1/2 x. So I had 2 cosine of 1/2 x. And that's my equation. That's it. Yep. I'll make sure I'm out of the way. And this work will be saved and uploaded in the same folder as this. But I get it. You know, you're writing it down live with me right now. You know, I don't want to just be like, oh, just wait till I upload it. So yeah, 2 cosine of 1/2 x. Yeah, the work I did for finding your period, if you want to show me the work you did there, in case you made a little mistake, you could, again, upload that work or try to type that work out for some partial credit. But again, you know, I get it. These calculations aren't overly complex. You know, I can trust that solving something as like this isn't too crazy to do. I can trust you can do that without showing me the work. Okay, find the equation of the graph below. I thought I made this 8 questions. It's down to 6. Sweet. So here with this, first off, I need to figure out if it's sine or cosine. Let me just copy this. I'll put this in Smart Notebook. This way I can mark it up better and do all that great stuff. So, paste. Come on. Paste. Optimize, and then I need to scale this down quickly. So we're going to need to find the amplitude and the period by looking at the graph. And look at the graph to determine what function it is. So this is number 5. So right away, I notice it starts up here at 2. So that tells me I already have an amplitude issue, because usually sine and cosine peak at, or go low at -1, high at 1. So since this is going up to 2, I know this is going to be 2 times whatever function. So again, if you're having trouble remembering, oh, which wave starts at what, I'm going to refer back to my memorization of the unit circle. So at 0, my x value is 1. My y value is 0 at 0 radians. So if I'm starting at a height of 2, that means I probably did 2 times 1. So that was my x value was 1 at that starting position. So that's telling me I'm a cosine graph, because cosine's my x values. You're like, Iskov, I don't remember all that stuff. You're saying a lot, and I hear you, but watch this. Having a little trouble? You could just go cosine of x, sine of x, and oh, okay, yeah, cosine starts here. Cosine was the one that started at a max. So yeah, okay, that's a cosine graph. So right away, I know it's cosine. Now my amplitude goes from here. Oh my God. Let me recalibrate my board. The writing's off, and for this, I want to be very accurate. So I know it goes from a center line of 0 to a maximum height of 2. So that tells me I have an amplitude of 2. And again, amplitude of 2 just tells me that's 2 times the cosine of that. Now my period is how long it takes to repeat. I don't think I did. I did this on your review. Wow. I don't think I did this on your test. I still have a question or two left to edit. This is actually the same answer as the last question. Just actually exactly the same, because yeah, we were talking about cosine graph. This goes from here to here. So that tells me that's one full period when I went from one peak to the other. So that went from 0 to 4 pi. So that tells me my period equals 4 pi. So again, I'm going to go through the math of solving for B just to reiterate that. But yeah, you already got it because we just did it. Yeah, so it's basically going to end up being 2 pi over 4 pi is my B value. 2 pi over 4 pi does reduce to 1/2. Somebody did put that in the chat, and you're right on top of it. Great job. So again, yeah, it could be like 4 pi is equal to 2 pi over B. Actually, I know we talked about this the other day. We could do that swap thing because our variable's in the denominator. So B is equal to 2 pi over 4 pi. The pi's cancel. 2 over 4 reduces to 1/2. So that will be the cosine of 1/2 x. Now you go, okay, we have a picture of this, right? I'm going to utilize the picture to my advantage. So it looks like my y-axis goes from -3 to +3. My x-axis goes from like 2 pi to 7 pi about. And then my steps on there are pi. So I'm just going to try and graph this on Desmos. So I said my graph is y equals 2 tons of cosine of 1/2 x. So that's what my graph looks like right now. I want to scale it to how I scaled the picture, though, -3 to +3. Then my x-axis, it looks like it went from -2 pi. Oh, wait, I did that backwards. X-axis goes from -2 pi all the way up to, it looked like 7 pi or so. And then had a step of pi, so it was counting by pi's. And then my y-axis went from -3 to +3. So I rescaled this, and this is what I see. Let's take a look at our picture. Okay. Yeah, that's looking good, right? So yeah, that tells me my equation looks good to it. So again, we did a little bit of work there. A lot of it was just reading stuff off the graph type work. So if you're just writing your final answer, that's okay. But if you're writing some additional stuff like we did on the whiteboard and you want to share that with me for potential partial credit in case you mistyped something or just calculated something wrong, you can always upload that so I could be like, oh, okay, that's where your mistake was. And the final question. So ladder is a ladder that is 20 feet long is leaning against the side of the house. The angle of elevation is 80 degrees. Find the height from the top of the ladder to the ground. So I want to know how far up the wall this 20-foot ladder reaches. So picture time. So this, look, I don't care how good you think you are with this. Drawing the visual picture is going to be what helps us here. You do not have to be an artist. It does not have to be accurate, but drawing the picture is just going to help you see what's happening. So I have a house here. Very poorly drawn house. I don't even know what's going on with that side of the roof. There's a door, some windows, whatever. Now I have a house, I have a ladder coming up here. So again, it doesn't have to be great. I know the ladder is 20 feet long, so I know my hypotenuse here is 20. I'm told the angle of elevation is 80 degrees. That means from the ground going up, that this angle right here is 80 degrees. Remember, we're in degrees here, so when we're going into Desmos, you must click the wrench, change from radians to degrees so it calculates correctly. Now, what I'm curious about is this over here. How high up the wall or the side of the house will this ladder reach if I put it at an 80-degree angle? So that is my opposite side. 20 is my hypotenuse. Sine uses opposite over hypotenuse. So I can say the sine of 80 degrees is equal to my opposite x over my hypotenuse 20. This one, again, if I'm doing this on the test, I'm working it out on scrap paper or like somewhere, like maybe screenshot it or whatever. Like if you have something you can write on neatly digitally, screenshot it, then upload it. So here, multiply both sides by 20. And 20 times the sine of 80, you're going to have to grab a calculator for that. 80 is nowhere on the, well, 80 degrees will be like right here on the unit circle. However, we don't know that exact value from the unit circle. So this has to purely go calculator here. Again, I need to make sure I'm in degrees. So I switched that over. And notice what that did to our graph. That's why we tend not to look at graphs in terms of degrees and really focus on radians. But that was just 20 times the sine of 80. And that tells me my ladder gets, wow, 19.7 feet up there. So it nearly gets up 20 feet. You know, thinking about how steep of an angle 80 degrees is, you might not want the ladder that close to straight up. You might want to just scooch it out a little further and maybe have it make more of a 75-degree angle, because this is like a third of a foot away from the full length of the ladder. So, you know, I think I might scooch that ladder back just a little bit, make that angle slightly less steep. So if we see if this is a 75-degree angle now, that I lose almost more of a foot on there, but it was 80 degrees and it's almost the full length of the ladder. So that was, I'd like you to go 2 decimal places on it, 19.70 feet. Whoop. So that will be x equals 19.70 feet. So that's a pretty good reach for that ladder. It's getting the job done there. Again, I'm not going to bother typing this in. You guys have been doing a good job typing stuff in or figuring out how to take a picture with your phone if you're writing it down in a notebook, getting it to your device and uploading that. So, yeah, with this, I'd really like to see your work of drawing it out. This way, I really see where everything's coming from. And a problem like this, I will at least need to see the initial equation you set up. I don't just want the final answer. So that is it for our final review. 6 questions. Your test is going to be incredibly similar. Going to change up the numbers. I'm going to make sure that the graph you have to identify is not the same as one of the previous equations you made, just to really make sure we got it down. So I really didn't see any questions pop up. So thank you guys. I'm going to stop recording.